Good afternoon, everyone. Today lecture is the 16th lecture in our course of machine learning. And the topic of today that we will talk about how to combine machine learning algorithms and also very small part about generative AI. And finally, we conclude with the ethics of AI. Uh, the first thing that after being together in 15 lecture where we visited different algorithms in all three or four actually types of algorithms, those of supervised learning, semi-supervised learning, unsupervised learning, and finally last lecture was about reinforcement learning. And during this journey, we visited also different kinds of algorithms and different concepts where the algorithms were based on from each of these categories. So we have seen, for example, regression, linear and nonlinear regression. We went through neural networks, slightly about extended these neural networks, the multi-layer sorry, when we have many hidden layers with deep learning, and also visited the probabilistic approach where we show some parametric classification or classifiers based on Bayesian theorem, for example, and support vector machines, trees, KNN algorithms. Also in this, also about the data cleaning, the data quality enhancement, like reduction, data or space reduction algorithms, support vector machines, and in the clustering, we like k-means and expectation maximization algorithms, um, hidden Markov models, finally the reinforcement learning. So many different algorithms we have seen, and now the question is which one is suitable for your application. So after this course, I suppose that you know now different algorithms and the application of each algorithm, the capability of each algorithm, and now you are in a situation that you need to apply machine learning for certain data in your company or in your thesis or in your work in general. Um, there are some general guidelines that it can help you. For example, is your data labeled, and are those labels are reliable? It means that can you trust them? No bias, not like distorted data. So in this case, of course, you will suppose to use supervised learning. And if your data is unlabeled, or the labels, they are, you cannot trust these labels because you think that it is biased, or maybe after the learning, after you try the supervised learning, you find that you were not able to find a reliable algorithm that it works fine with in the part of in the validation test on the validation part, and you try to change different algorithms, but it didn't work. Then you start to think that maybe the labels that I am using in this algorithm are not reliable. So in this case, maybe you can think also about recovering the hidden relationship or the structure of the data by using unsupervised learning. Or maybe you have a small part of the data labeled with labels that you trust. Then you can use semi-supervised learning, and so on. So those are the general way how to manage with your problem. However, there's one thing very important, that your experience in the application of machine learning, it comes with time. It means that you need to try a lot of many times, so you are part of this process. as a data scientist, you are as a data scientist or as a machine learning like expert, you are part of the process. What does that mean? It means that as you try and as you test your algorithms, your experience will increase. And after like long time of working in such problems, you start to have a sense, that this, with this data, with this problem, I should use that type of machine learning or algorithm, I should use that number of layers in this hyperparameters, certain hyperparameters. No, this data, it is better to use support vector machine. It works much better than that algorithm. So do you need your algorithm to be transparent or not necessary? So if your algorithm must be transparent in the case that you can explain how it works, you see how things are done there. So in some problems that we need our algorithm to be transparent. So in this case, we shouldn't use black box algorithms like deep learning and neural networks, for example. So it depends on the application, it depends on the type of data, it depends on your experience. This will be accumulated with time. Okay. Uh, and there's also important advice for you as a data scientist. So the cleaning and pre-processing of your data, it can be extremely important. It can be in some cases your algorithm will not work without doing this step. So you should be able to understand your data, and also to clean, removing if it is noisy data, or there is a lot of redundancy and so on. So you can use support vector machine, for example. Oh, sorry, you can use principal component analysis in order to reduce the size and at the same time removing the redundancy of available in data. So it is important also this step before you start the machine learning algorithm. The dimensions of data. So if you are working in hospital, so don't drop any piece of information, even small pieces of information that might have big impact that we don't know. It means that, for example, during the analysis of certain patients' data, so I don't know what kind of information that they are not. You might feel that they are not important, but for example, the color of the hair color, for example, is it black or gray, or maybe something that every like doctor in hospital think that this information is not important, okay, about that kind of disease, that if the person has a gray hair or not. But maybe when you add this information in your data, you find, wow, yeah, I mean, the accuracy of your prediction increased like with considerable percentage by adding this information. You don't know. So because actually, if we know the model exactly of the data, we don't need already machine learning. If we as a human, we know that the relation between the attributes and the result, why we use machine learning? No need for machine learning. But we use them because we don't know how these attributes affect the output. So, and we want the machine learning to be able to extract this information for us. Okay, so don't ignore any information. Anything could be added in the data, you should add it. Okay, so this is very very important. Okay, so choosing the right machine learning algorithm depends on several key factors. So we have, for example, the accuracy that you want for your result, the complexity and computational cost. So sometimes some algorithms would need a lot of computational resources. For example, if you have data, pictures in hospital, like pictures of X-ray, and then you have maybe hundreds of thousands of these pictures, and you need to have like deep learning algorithm in order to analyze this data. So do you have the facility to do it? I mean, do you have, for example, GPU for the learning, and you can scan, or are those data already digitized or not? So all these things needs to be taken into account. As I said, that it is needed to be transparent or not. It is the interpretation of the result. Is it like necessary in your algorithm or no? I don't need to my algorithm to be transparent. It is enough that it works. So it depends on your like approach. Scalability as well is important, and actually in some algorithms we need to have continuous learning. What it means that you have like off data. So you have off learning means that you have a lot of data already, so you apply them to your algorithm has catched the relation, it works now. But as we have a new data coming, okay, so we try all the time to continue update our algorithm in order to be improved with time. So also we need to take this into consideration. Okay. uh, Now what if um, you as a machine learning or as a data scientist, when you applied all these algorithms individually, you didn't get enough accuracy? So you applied the neural networks, you applied like different hyper parameters, different number of layers, different number of new spell layers, different activation functions, and so on. And whatever that algorithm that you were used, some algorithms better, working better than other algorithms, but in general you was not satisfied. You didn't get good performance on the validation set. Okay, so your validation set, it was working like maybe the best case it was 65% or 60%, and you was not happy with that. So are there other way that we can do? Yes, actually we can combine those algorithms. We can combine several machine learning algorithms. The question is it always working? The answer is not, of course. Not. It is not necessary that when you use combination of machine learning algorithms that it will always work. There is no guarantee for that. Why? Because some of your data might be the lack of accuracy might be due to missing important information in your input. So missing information in your attributes, for example, there are some critical information missing. Those critical information we don't know. We don't know that this information is needed. Okay, or even it didn't come even to our mind that we need this information, or this information is hard to obtain. So in this case, whatever machine learning you use, it will not be able to improve the accuracy to, for example, to reach 90% or 95% or such kind of high level of accuracy due to like in principle due to lack of information in your data. But many other times that this lack of accuracy not due to the lack of data or of information, but due to the capability of these machine learning algorithms. So either in classification or in regression. Okay, so in this case, we need to combine several machine learning algorithms, because your data, for example, it might within your data, you might find that your machine learning working fine with that set, but it is bad with that set. Okay, sometimes you have like a dynamic type of data, or you have like a non-stationary type of data. In this case, maybe your data is working well for certain situation, but your algorithm, sorry, and is in other situation you might find that another algorithm working better than this algorithm in different portion of data. Okay, of course, it is not wise to use different algorithms if they are working with several with similar performance. For example, if you have using like neural networks that it works very good, achieves like let's say 70% of validation, but it works very well in some kind of data characteristics. And then you use support vector machine, which also working like maybe 70 or 60% good, but it is performance is also within the same set of data that in neural networks was already better than support vector machine. So there is no sense here to combine both of them. And neural networks is better than support vector machine because it works good for that data set. But if when using a neural networks, it works fine for certain set of data, but it works bad for different set of data. And in sometimes or in the same time, support vector machine with certain kernel function, it works good for that set of data that in neural networks didn't work well. In that case, we can combine both algorithms to achieve this requirement. Okay, without taking longer time, so we have three kinds of combination. It is called packing, boosting, and stacking. Okay, so what is meaning of bagging? Bagging actually is using multiple neural networks or multiple algorithm, but don't different. They are not different kind of algorithms. The same algorithm, but with different parameters. For example, you use a neural networks with one layer, a neural networks with three layers, a neural networks with 10 layers, and you combine all these neural networks with different hyper parameters in order to improve the result. Because with some data, maybe it is more linear type, so single layer neural networks works fine, but some set of data where we have like complicated relation, so using a single layer of a neural networks will be underfitting, and you using that multi-layer neural networks for this part of data which is more tend to be linear, it will be overfitting. So in this case, using different algorithms under the same algorithm that you use. So in this case, it will provide you some diversity, and it can provide you better like algorithm against to be underfitting or overfitting. So it is called packing in this case. One type is called also random forests. Random forests is just a tree that we have seen, but instead of using single tree, you use multiple trees. So when you use multiple trees where you can divide the data according to different criteria, so you will have different type of trees, and this is the name that it comes first. And after that, you can average. For example, you make averaging over the results of different trees, or also you can take different kind of statistical averaging like median and so on. The second type is called posting. In the posting, actually, we try to improve the model that we use in the set of data where we find that it has misclassified much. So, for example, if you use certain algorithm, it works fine. In the validation and testing, we find that it works fine for most of the data. However, there is certain situation where the classification misclassification or the classification error becomes very high. Like for example, most of the data we have classification misclassification, let's say 5%, but within certain situation we have like the misclassification can be 30 or 40%. So now we focus on this part of data and we try to improve the classification. So we are using sequential type of machine learning. So in the first we classify the data based on this which works fine, but for those which working bad, we can use different algorithm and focus on this data, how to design a special algorithm to treat this problem within this kind of data. So it is called posting algorithm. And finally, we have a stacking algorithm. A stacking algorithm that we use different models. For example, you use a neural network and you use support vector machine and you use Bayesian based classifier and so on. So when using different algorithms, then you can make some voting or averaging between these results, as we will see later. So in a stacking algorithm that use different machine learning algorithms, when remember when you have different results, because if I use support vector machine and neural networks and both of them, they are most of the time they are aligned with each other. It means that both of them they give the same result most of the time. No need, just you use more computation in no need. But if support vector machine and the neural networks give different results, sorry, different results, but the accuracy they both of them they are if you treat every one of them separately, you can find that the accuracy is comparable. For example, UNetworks gives you 85%, support vector machines gives you, let's say, 75% correct answer. And when you look to both the results of both of them, you didn't find that, for example, 100% or 90% they are similar. So there are some differences in the result. However, both of them they are working in good percentage. What that mean? It means that some of those misclassified by neural networks, it was classified correctly by support vector machine. And also those which were misclassified by support vector machine were classified well by neural networks. In this case, combine both algorithms can be beneficial for you. Okay, and in this case we call them as stacking. But how could we combine them? We one way to do it by voting, as we will see, or averaging, or by using meta learner, as we will see. Okay, okay, that I those I explain all these. Okay, so actually, there is a theorem called no free lunch theorem. What is that no free lunch theorem? It means that simply that there is no single learning algorithm. It will outperform all others across all domains. You cannot say that in neural networks with certain number of hidden layers and the neurons, it will work and it will outperform all other algorithms in every situation. This is not possible. Okay, this is not possible. So every algorithm it has certain space where it works fine. So you should remember this no free lunch theorem. And all learning algorithms are inherently ill-posed problem. Are inherently ill-posed problem. What is the meaning of ill-posed problem? Ill-posed problem is the problem which is not well-posed. What is the well-posed problem? Well-posed problem that based on Hadamard definition satisfied three conditions. First, a solution is always exist. Okay, the solution is unique. So your solution is always is unique. You don't have other solution. And the solution depends continuously on the input data. It means that even a small change in the input data, it will lead to a large change. It leads to small change in the output. Okay, so it means that if you have, let's say, 20 dimensions data that you have 20 dimension, 20 attributes in your machine learning, and then if you add one extra, so you find one extra, so you add it, it is supposed to add the accuracy very little, because adding small changes in the input data will lead to very small change in the output. So if you have all these three conditions, we call this problem as well-posed. But in general, machine learning all machine learning algorithms are ill-posed. They are not well-posed problem. So usually we don't have a unique solution. Okay, usually you cannot guarantee that the solution exists always. Okay, even if you try that, you find it working well for your data, but this is the data that you have. But what if you bring another data? There is no guarantee. One of our one of our research results that we produced with one of my ex-PhD students, who is now a senior researcher in Helsinki University. Uh, we collected data for the tongue cancer, and we applied machine learning, and it was working. We tried different with this like bagging different hyper parameters, and until and we applied also different kind of algorithms. We applied stacking as well. So we combined different results until we reach very nice result. The accuracy reached 90%, okay, of the prediction of the patients. But when we bring new data, or when we start to collaboration with different universities in different countries, and they apply their own data, so we found that the accuracy dropped to be 60% instead of 90%, that the data that we use in order, and we tune our algorithms to work with this data. So there is no guarantee, whatever was the accuracy of your algorithm, that it will work everywhere. So this is the reason that we need testing part, the testing part, or the overlooking part. All the time you need to overlook your how your algorithm is working and to improve it all the time. Okay. Yes. So as I said, that this is a combination. So I show you now how to combine the data. So you can take the average, for example, or you can take the voting, like in this way. So you can collect the data from different machine learning algorithms. So this is the output of every machine learning. So we have yes. Let me go. Sorry. Yeah. So now you have D-based learners. So you have different learners, and then you have like D1, D2 based on the parameters and data that you applied, and then you will have output. Then we can apply certain function between these outputs from different machine learning algorithms, and then we can use like in this case. Okay, so this is learner number one, algorithm number one, algorithm number two, up to algorithm number L. And then you can take this like weighted summation of them, and those weights can be just normal sum, like normal weight, or the average. It can be weighted sum. So, for example, you know that the neural networks in regression gives most of the time better result than support vector machine. So you can give higher weight for the neural networks and lower weight for the support vector machine, because still support vector machine can give, or it has also some information that missing from the neural networks. So you want to get the benefit from both. So maybe you get the weight 70% for the result of the neural networks and 30% of the result of the support vector machine, for example. You can use median, you can use the minimum or the maximum. So you can have different type of criteria in order how to combine those results. You can use also what is known as meta learner or machine learning based combiner. This is very interesting actually, because in this case you apply like two steps of machine learning. In the beginning, you learn every algorithm separately. So this is machine learning number one, machine learning number two, up to machine learning number n. And you can use different data sets for each one of them, not necessarily that you use the same data set. And once everyone is learned now, either in classification or in regression, okay, now you take the output of each machine learning, and then you use another step of machine learning. So now we have another machine learning based, for example, in neural network, like one layer or two layer. If it is linear combination, it is one layer. If you want to use non-linear combination, it can be like two layer neural networks, where you take the output of each machine learning, and then you adapt the weights of this like back propagation neural networks, normal one, and in order with, maybe you can use both data, or you can use different kind, especially if you have like plenty size of data that you have. So you can bring another set of data in order to improve the result of all these algorithms. So it is very interesting. Not necessarily, as I said, that it will lead you to have better algorithm. It might not work. It might work. It depends on your data. It depends on your algorithms and many other aspects. Okay, so this is the generalization about the how to combine different algorithms. About generative AI, as I said, that I have to hurry up a little bit. So generative AI, in the generative AI, the first question: what is generative AI? Why I didn't explain generative AI in a separate like category? Because we talk about supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. But generative AI, we didn't talk about it. The reason is that generative AI is combined or is formulated based on these four algorithms. It is not separated algorithm. Okay, so it is based on all these algorithms. And I explained this in course when I talk about Bayesian theorem and giving them like probabilistic inference of generative AI and how it works. I explained this already before, but now let us talk fast about the algorithms now in the area, because it is still new, especially this the highest or the the fast accelerated algorithms and performance came within the last 5 years or 6 years. Actually came after the development of new concepts, how to generate AI or generate new text or new figures or new content in general. Okay, so what is generative AI? Generative AI is generates new content, as I said, text, music, images, anything where there is logic. Remember, if you have certain thing connected to each other within certain logic, okay, and we can generate the same logic, the same content, then it might have some meaning for us as a human. Generally, generative AI generates new content for human, for us. And if you look to our walking, our talking, our pictures, our faces, everything, it has some like an uncertainty, but it has also it is regular uncertainty. What is the meaning of regular uncertainty? It means that it has some logic which is represented by the probability density function. So probability density function is the logic which contain the uncertainty of our talks time series in our words, in text, in our scene, in pictures, and so on. Okay, so now how is it different from traditional AI? Instead of classification or prediction, it creates a new data similar to it is trained data. Okay, so you should know this difference, because some people they mix between generative AI and say, okay, now in generative AI I don't need any more classification, I don't need hidden Markov models, I don't need. No, this is wrong, because you still need to classify your input, you still need to predict, you still need to make regression, all you need this algorithm, you need to cluster your data. Okay, you should, of course, you can use this now generative AI as a tool. Now it has been like there has been a capability added to these algorithms of generative AI, that they can use these tools in order to analyze your data. Yes, this is true. So generative AI as an algorithm like ChatGPT, they have the capability to use our algorithms that now we teach them in this course, or we gave them in this course. They have the capability to select the proper data and to do this process for you. This is possible, but not because the concept of generative AI, the concept of generative AI is to generate a new content, not to classify existing content or to predict or to make recreation and so on. The application, of course, as I said, that we can in chat bots like ChatGPT, in image generation, and so on. What we see in the front of us now is we have different ways for using or behind generative AI, like the encoder and decoder algorithm. It is very simple, as you can see in front of you now. So you can see here that, for example, if you use a neural network, let's say you use hidden deep learning with it takes images, and those images that, let's say, 1000 by 1000 pixel, so you have 1 million input for your sorry, okay, I have a call now. Yeah, sorry, as I said that we have meeting, but I can they can wait a little bit. So now, as I said, that we have for example, deep learning neural networks, for example, assume that you have here in your input data, you have, let's say, 100,000 input, for example, okay? And then use multiple layers, like 100,000 input, now you have, but in the output, you use 100 output. Okay, use 100 output, and then after 100 output, you has the decoder. So the decoder is still the reverse way of your encoder. So the reverse way that you have in your encoder, you have them in your decoder. Okay, and you applied your input here, maybe images, and you start learning the adaptation of your algorithm until you get the same output again. If you didn't get the same output, it might be that 100 output here in the middle is not enough to represent your data. So you start to increase it until you get the output in the output of the of your encoder and decoder algorithm. Okay, once you apply, for example, thousands of images and you get the correct thousands of images, what is this in the middle? So even if the image, just example, of course, is not necessary to be true in these numbers, but just example, if the input 100,000 and you got it again 100,000, but in the middle you find yourself that you need only 100 to represent this data. What it means? It means that this 100 neuron or 100 output or the vector with 100 elements is enough to represent this 100,000. This could be used for compression for your data. So this could be used for your compression. And also, this can be used for latent representation of your data. What it means? It means that if within 100 space, I can build my distribution, my probability density function distribution with 100 space to represent images within 100,000 space. Because every vector here is 100,000. It is very complicated to build like probability density function with 100,000 space. But now within 100,000, only 100, which is 1 per thousand, we can build it will be intended, or it will be compressed information. So all information are here now. Then, if I can generate another like similar distribution with 100 dimensions, similar distribution here in this part, okay, then I can generate similar output of the output that I was using. For example, within these images, for example, image production, AI based image face, either a human face or animal faces or whatever that number of or type of data that or content I am looking to generate. Okay, we have this is actually called like versional auto encoders, VAEs. So this is the concept how it works. We have also this GANs network where we use a random number and this is the generator model. What is the generator model? The generator model actually is a model based on a clustering. So in the beginning, for example, if I want to have the human faces representation, or what will be the probability density function of the human faces. Then I bring thousands of human faces and maybe another thousands of something else. And I start to make clustering. machine learning clustering. This is unsupervised learning. So in this clustering, I try to make an algorithm that it can cluster all human faces together and non-human faces as another cluster. Okay, so in this case I will have some kind of like a built-in probability density function which can catch the human face or the content that I am looking for. Okay, then we can actually generate some random signal based on this clustering by applying some random input based on this clustering. So if this generative model said that about this random input that this is a human face, because it is only clustering, remember this is only clustering algorithm. So if we say that it is a human face, then it will be like fake generated example, and then we compare it with another real example, and then we use some discriminator model. So this discriminator model, it will say that is if this is real or not. Then we have binary classification. It is like some kind of reinforcement. This is correct or not correct. Correct or not correct. In this case, we can use some kind of adjustment for the parameters for both the discriminator and the generator model in order to have or to generate like useful content for us. In the text, in the large language model that we see today, they use what is known as like attention based. Okay, so this is one of the highest or the most impactful new algorithms in order to generate meaningful text in any language, as we can see today in the chat GPT. Actually, if you remember when we talk about Markovian process, we said that the output of the Markovian process depends only on one, like previous on the current word. You can expect what is the probability of the second word. Okay, let us talk about visible Markov process, not hidden. Okay, and now we said that in this case, the generative model, it will be very low limited, very low, and it will has a very low accuracy to generate long text because it depends only on the current word. The next word depends on the current word. Okay, and I showed before that we can use different words, like for example, we can use like in order Markovian process where the output depends, like let's say in the previous 10 words, for example. And I showed before that this could be very complicated. It will need a lot of like a huge number of trials in order to build the probability in each situation. Okay, and even if we do that, for example, by using deep learning or using, you know that this recurrent neural network, in the recurrent neural network, it do the same. Actually, it did the same because we have memory there, and in this memory, we can keep, let's say, the last 10 words or the last 10 tokens. Tokens is like splitting the text because finally your machine learning does not understand what is the meaning of words. We convert these words or text or letters into numbers, and then we can split the text into tokens. Tokens can be words separated or can be a set of letters and so on. Anyhow, we use this in the recurrent. Sorry, still people try to contact me because of the coming meeting. Even the time is still for the meeting, but maybe they need something else. Anyhow, um, so in this text that we have, for example, the last four or the last five words and so on, we can keep them by using this recurrent neural networks where it has a memory gate that it can keep those words that in past there. So we don't need to go through that like looking for every and trying all possibility as by using this like statistical algorithms, and as explained that it will need a lot of time, a lot of resources. However, even in the recurrent neural networks, it was not working well. The reason of that The reason of that, because in this recurrent and neural networks, they assume that all words, okay, especially those are closer to the current word, they have the same importance in the text, and this is not true in our spoken language. In our spoken language, we have different attention about the words. There are some words, they are there already, but if you remove them, if you remove them from the text, it will not reduce your understanding that much. But there are some words which are the keywords in every text, that if you remove any of them, then the meaning or the message will be completely the quality reduced, or maybe you will not understand anything. Maybe there's some word, if you remove some text, if you remove one word, the whole understanding will be gone. I give you example. If there are some, if you didn't find your mobile phone, and then someone told you, uh, took it. He didn't mention the name who took your mobile, but he said took it. Someone took it. What is the information here? You lost the information. Okay, you know that it was someone took your mobile, but who? You are looking for the name. Now, all this, the text, all the meaning, base it on single word. Okay, so if they said, for example, Sami, if you are looking for your mobile with more mobile, and someone say Sami, and you know Sami, your friend, okay, so okay, directly you know that Sami took it, even without completing the word. But if they say took it, okay, who took it? So in this case, that guys, researchers from Google Lab in 2017, they built very strong, very nice algorithm which can give some weights for the importance of the words within the text. So they call them transformers and self-attention, which can compute the relationship between the words efficiently. So it means that if they remove some word and they measure the importance or the impact of removing this word in the whole text, then they increase the weight as far as the importance of this word increases. And it is in dynamic way. For every text, we compute different weights for every word. The paper published here, it is published in 2017. I will upload it in the module. You can find it anyway, but I will upload it in the module so you can download it if you like to read this paper in more details. Okay. Final thing in this course is the ethical issues in machine learning. Okay, why ethics matter? Why ethics matter? Ethics in machine learning ensures fairness, transparency, and accountability, preventing bias, discrimination, and misuse while protecting privacy, human rights, and societal well being in AI driven decision. So this statement is very important. It concludes the whole most of the topics in ethics matters in AI. So you need fairness. So the because we have some AI based decision, for example, in hiring a new workers, for example, in certain company, and there are thousands of applicants. It is hard for a human to count and check the applications for everyone. So we rely on the AI in to classify or to select the most proper person for this work or for this position. In Amazon, they found a couple of years ago that it was biased against female. So the Amazon, they found it was giving higher hiring percentage for male over female. Then they decided to remove the gender information from the application. But they found it is still biased. And based on that, they conclude that it was biased because of the names. And it was biased because of the data, that previous data it was used during the learning. During the learning, maybe the data itself was biased. That the data it was showing that, for example, those with female names giving not high scores in the work, those with male giving higher score, or something like that during the learning. So in this case, actually, it is not fair. It is not fair to treat people based on other people's what they did. So this is big question here. Is it fair? For example, if you are from certain race, okay, and most of people in your race, not most but many or considerable number of your people in your race, in your skin color or whatever, they were doing something, and is it fair that you are treated against your people what they are doing, or the percentage, for example, if your people what they were doing, is it fair in that case? And especially if the data was not balanced. I mean, if you come to like certain European country and 10% minority, for example, of certain race, only 10%, 90% from the majority part. Okay, so in this minority, the percentage of this minority, those are criminals, for example, is 1%. And the percentage of the criminals in the big minority, 90% people, it was 0.5%. Okay, so 0.5% actually, as number of people, is much higher than those who are in minority. But still, in machine learning, in statistics, they will assume that the minority range, the criminal percentage in this minority is much larger, and they start to bias against you. So is that fair? Maybe you have not commit any kind of even like overspeed or parking in wrong place in your life, but still you are treated according to that. Actually, in our life, there are many things unfair, actually. For example, if you are from certain country and you carry certain passport of that country, you are not allowed to go most of the, for example, it is not allowed for you to enter 90% of countries in the world. You, still the same name, still the same face, still the same, everything the same. As far as you, or as soon as you get the passport just book for another country, then all country gates open for you. So there are many things actually that it comes to the ethics of the and even this one is maybe is not directly related to AI, but in our human life there are many things, many questions open. Also, the transparency of the can you explain why this machine learning takes that result? So the transparency is part of the ethics. Some people, they don't believe in, they believe that block or black box machine learning is very good, very strong, but they believe that they shouldn't be applied where there are any kind of decision making, because every decision must be transparent. Okay, and accountability. What is the meaning of accountability? Who we can blame if the AI based decision maker made something, it was wrong, it caused damage? Who should be accounted? Who should go to the court? You cannot take your computer to the court. You cannot put algorithm in jail. Who should pay for this damage? Accountability issue is very important. It's under a lot of discussion in the ethics. Okay, again, preventing biasing, preventing discrimination, and also the misuse while protecting privacy. For example, what is the fuel of machine learning? Is data, data of people. When you collect data of people, who can guarantee that this data will not fall in the wrong hands, that they can get benefit from this data against some others? Human rights. Now AI can be used as engine which control weapons. It is very bad because this machine learning is machine for killing. Those machine learning don't have any kind of mercy. It depends on the programmer. Okay, so if you say that shot in head, it will do that. As a human, even in the war, even in the bad situation, maybe when they see some person that in bad situation, like a very old person or kid or something, even if to protect themselves, if even if they enforce it to shoot, sometimes they shoot on leg, they don't shoot to kill. Because as a human, yes, we a human usually they are can be actually very bad in many situations, but as individuals you can find some people with mercy. But now if you put everything within AI driven decision, drone with AI just killing people. I mean, there are many matters now when we talk about ethics of AI. Also the impact on the AI in the society. The this Like for example, taking the positions of people. For example, now they say that after a few years, it is hard to find available jobs for the programmers because AI can generate all codes that we need. Yes, still we need a human, but those who are like very very high skilled people, that who's not average, is much more than average, is the top 5% of programmers. We still and we will continue need them in order to check those generated by AI and improve the codes there. But most of the workers as in which who are average programmers, maybe they will lose their jobs. And also the misinformation and deep fakes that it is generated in this AI, it has very high impact. The control of the society control, society engineering, how to play with emotions of societies, how to change culture, how to change beliefs. So there are a lot of ethical and legal changes here. Okay. Actually, I explained most of these things here. So, but anyhow, finally, in the future, we should think that future AI ethics should include more and more transparency, accountability, bias mitigation. Of course, you cannot prevent biasing 100%. No way. No way. No way that you make the biasing zero. The problem is that every bias could be justified. This is the problem. It can be justified. And what is accepted justification for you, it might not accept a justification for me. This is a problem. We are diverse. We are different in people in the world. We have different background. We have different culture. We have different beliefs. Okay. Privacy protection. It is important. A human oversight, a global. We need also some global like regulations that respect other society beliefs, religion, culture. We shouldn't like enforce using AI in the future in order to be all of us like one copy from each other. Every country, actually, our beauty in our diverse, in everything. Maybe in our shapes, we are not that big diverse, so we are quite similar, human. We have all we have the same hands, the same head, the same eyes, similar eyes. We have the same structure as a human, the same brain. we are very similar in that sense, but uh, our difference in culture, in background, in way of thinking, in languages, all these things gives us this beauty of a human. So, in order to use AI and and machine learning to unify the way of thinking, or to enforce people everywhere to be the same, looking in in ethical matters, what is wrong must be the same for everywhere, and what is accepted, what is justified, must be the same everywhere. So, of course, this will not be good in the sense that there is no pure or absolute right and absolute wrong. In many of cases, of course, there are some which we have absolute right and absolute wrong. We have a few, but for the others, depends, as I said, depends on your culture, depends on your environment, depends on your belief, depends on your site, depends on your principles, depends on many other things. Okay, so uh, let me stop here. I am already late for my next meeting, but please, thank you very much for being in my course. I hope that you get benefit from by attending this course. And unfortunately, I will not have time to open the discussions, but still, you can write to me, or you can write directly to Model if you have any comments or any discussions that you want. I will keep the Model open for some time, at least for 1 month. It will be open before it is hidden. So in this case, that we can keep it like forum for exchange ideas or discussions. Okay. And please don't forget the feedback for the course. It is important to have your feedback, either in EUNIS or in Alto, or sorry, in University of Vaasa. So we have feedback platform where you can put your comments there. It would be nice to hear your comments, to be nice to hear your feedback about how to improve some things, or if you feel that it is good if we increase the dose in that topic or reduce that topic. So it will be good. I am using this feedback actually in order to improve. So what you see every year, I change slides. They are not the same. So, but of course, not changing completely, but at least 1% of the total number of slides, or 2%. A change it based on your feedback, increasing something, removing something. So it is good to have your feedback. There is a question when we get the credits for this course within a few days, like within 2 days, you will get the credits of this course. For those who are in EUNIS, I don't know how to transfer the credits yet, but at least I will transfer the credits to our EUNIS office in University of Vaasa, and maybe they will transfer the credits to the EUNIS platform. Which should be the limit of using AI like ChatGPT for students in the university? Um, yeah, it is important question. Again, I cannot say that what my opinion must be the absolute right. Okay, but for my students, at least, if they use ChatGPT in order to solve homework directly, just take the homework, put it in ChatGPT, or the exam or the quiz, put the question on ChatGPT, get the result, put the result. This is cheating. No question about this. About for me, it is cheating. It is bad. The students will not get any benefit from attending this course. They don't have the option to, or the capability to improve their weaknesses. Okay, so they don't know how things are going, especially for those who don't attend the lectures online, or even some of them, they don't watch the online lectures. They just come to the quiz. They take the questions, put in ChatGPT, get the result, put it there, send it, get 10 over 10. Okay, who's the loser? You, the student, the cheater. I'm not loser. I'm not paying these credits from my pocket. Okay, and actually, the students he's the loser. He's the main loser for this by using this kind of bad habit actually. Because if I tell you one thing, here in Finland, especially in Vasa, there has been always some request for new engineers or new graduates who know ChatGPT, sorry, who know machine learning and AI. Some of the project managers in these companies, even in Nokia, in Varsila, in ABB, they contacting me frequently that they want me to like suppose or to suggest some names for them because they have summer job, and this summer job can be after that permanent, like with contract or something like that. The students who or those who graduated and they went there, they got 10, like 5 over 5 excellent grade in machine learning. But when they in the first interview, okay, they it was very bad that they know just very little about machine learning. They asked them some basic questions and they were not able to solve, to answer. Their answers was not in the right direction at all. They put themselves in very bad situation, and unfortunately I should say that some of them, even after several years from graduation, they are still working in some jobs that is not there's no bad job and good job. But when you get masters of science and technology, and you're still working in cleaning, it is accepted to working in cleaning if you are a student and you are preparing for yourself, and or you are looking for a job. But if you all your colleagues get good jobs in big companies, and this person he's still working in some job is not compatible at all with his years of study, because he was always looking the shortcut to get the grades. This is sincere advice. Don't do that. Try to be patient, to learn. When you get, even don't care about what people say about you that you get 100% in this course. It doesn't matter anything. What is matter is how do you feel yourself? Do you deserve? For me, I do prefer that I feel myself I deserve this 70% grade in this course much more than what people think that I got 100%. I don't believe in myself. So this is very important. Okay, now I come back to the question. How can I use ChatGPT? You can use ChatGPT to improve your like writing. For example, you are writing your thesis, okay? Even I heard that some plagiarism codes that can catch these cases. However, that I believe it is not a bad thing. You write your own way, you write that based on your understanding, but we are not English native speakers. So in this case, if I use ChatGPT as a proofreading, so when I write improve this text without changing the meaning. So they try to put R instead of is, maybe rephrase some statements to be more legible. In this case, I don't consider this as as cheating. I consider this as a good. It is acceptable for me at least. As I said, I don't say that I know the absolute rights here, but for me, for my students, I accept that. That he say that or she, hey professor, I use ChatGPT to improve my writing. It is okay. But if you, I ask you to write like a report or essay about certain topic, what is the application of hidden Markov models in in text recognition, and then you write this to ChatGPT, and the ChatGPT gives you text, and you take this copy paste. Of course, cheating. No question about this. It is just cheating. But if the what generated by ChatGPT, you as a student, you use them to read and to understand more and more, and to have to open some kind of discussion with that ChatGPT. That okay, I don't understand this point. Why to improve this point? Give me a numerical example, and to you make it as a tool to understand more and more. This is very good. This is the right way to use ChatGPT and other AI based algorithms. Okay, so important question. Thank you for asking this question. This is my answer, of course, but maybe you can think now my impression about this. In case that if you didn't get enough points to pass the course, or you are close to be passing, or you are close um, to be in another grade. For example, you can count your grade based on your points. So, for example, you find that your points was 78 or 79%. So you will get grade 3, but you want grade 4. Okay, so you can of course improve your grade by writing report. But remember, not every report deserves this jump. Not every report deserves this jump. The report should be excellent report in order to get jump from grade to grade, from 1 to 1. Also, for those who didn't pass the course, they get, for example, let's say 48, 47, and you need to get 50% in order to pass. Of course, you can also write the report. And then good report, it should be enough that you get a grade 1. But remember, for those who collected only 20 points or 25 points, sorry, for those students cannot pass whatever they write, whatever was the level of the report. So those who get can pass, those who get who close to pass, but they didn't get enough points to pass, but they were there. They were every quiz, or most of the quizzes. They did at least 10 quizzes in the course. Okay, but they didn't get enough points. So the report will be one option for them that they can do. And if the report is not enough to get the grade, I will inform you in feedback that you need to improve it in order to improve the grade. So this should be clear. And also, please don't use copy paste. Don't use again ChatGPT just to generate your report. This is not acceptable. Okay. For actually for this is important to remind you, for those who came from EUNIS program, we use different scaling than you. In University of Vaasa, the maximum is 5. Okay, 0 is fail. One, two, three, four. One is from 50% to 60 to 59. Two is from 60 to 69 to 69. Three from 70 to 79. Okay, and so on. So but in EUNIS, you use, I think, from out of 20 or out of 10. So I will not put the number. I will just send the percentage for you from EUNIS. I will say that this student get, let's say, 78%. So it can be, for example, 8 out of 10 or 9 out of 10, depends on the scale that you use in your university. For those who came from different university than University of Basel. I will use the best, as I said, the best 12 quizzes. It will be counted. The best 12 quizzes. 3 quizzes will be dropped. 3 bad quizzes will be dropped from the counting. So the best 12 students, the best 12 quizzes will be used in the computation of your grade. Okay, but those who didn't pass and didn't get enough points, but they are close to get the points, like get 45%. They have to be at least doing at least 10 quizzes. I mean, not collecting this 45% by doing only 6 or 7 quizzes and drop all the others. So anyhow, for any situation, you can contact me. We can have discussion about this. Thank you very much. I'm too late for my next meeting. So, a final word. Thank you very much, and don't forget the feedback. Thanks. Bye bye.